Solve another Leetcode problem 296, best meeting point. So we are having a m times n binary grid where each one marks the home of one friend and returns the minimal total travel distance. So what is the minimal total distance? So the total travel distance is the sum of distances between the houses of the friends and the meeting points. So we are not sure about the meeting points, but it depended on the Manhattan distance, and we should know the formula of the Manhattan distance. So for example, if this point 0 is the meeting point, so what is the minimum total distance? So from here 1 to 0 it is a 2, this 1 to 0 it is a 2, this 1 to 0 it is a 2. So the final answer is going to be 6. So this is why we're going to return a 6. So if you use another position maybe here, so what is the total distance? It is 1, 2, 3, 1, 2, 3, and 1. It is 7. Yeah, but here is a 6. So what about this one? Yeah, let's just try to use one more number. So for here, it is 1, 1, 2, 3, it is 4, 5, 6, 7. So for this one, it is also 7. Yeah, we cannot find any conclusions about this, but definitely if we just use the BFS, or the brute force, basically it is m times n times complexity m times n square. Yeah, normally we cannot pass it because m times n is like 4 times 10 to the power of 4 and 1.6. This square of this value is 1.6 times 10 to the power of 9. Definitely we cannot pass. Yeah, so this means we cannot use brute force. Now we're going to use some mathematical idea to solve the problems. Actually, this is a median problem. But first of all, let's just check a 1D array. So if this is a 1D array, we only have like 1, 0, 0, 0, 1. So what could be the point? What could be the meeting point? So maybe here, so what is going to be the distance? So this is 0, 1, 2, 3, 4. So this is going to be 4. So what about here? So this is 1, 1, 2, 3. This is also 4. So what about this one? 2 plus 2, it is also 4, and also 4, and also 4 here. Yeah. So this means if there are only 2 points in a line, so no matter which one, if it is just in between this one and this one, definitely the distance is going to be fixed, and it is 4. Yeah. But what if there are 3 ones? So let's just use the 3 ones, maybe. Yeah. So what if this is also a 1? So what could be the position? So yeah, let's just recalculate it here. So if it is here, so the distance, this is 0, this is 1, this is 1, 2, 3, 4, 1 plus 4, so this is 5. So what about this one? This is 1, 1, 2, 3, so this is 4. So what about this 0? This is 1 plus 1, 2 plus 3, 1, 2. So this is also 5. So what about this one? This is 1 plus 2 plus 3, so it's going to be 6. So what about this one? So it is 1, 2, 3 plus 1, 2, 3, 4. So this is going to be 7. So as we can see, so for each of the positions, the total distance is going to be different. But if we can get some conclusion from this 1D array, we find that it's going to be a median number of those 1, 1, 1. So we only consider those 1, 1, 1 because 0 doesn't matter. We only consider the ones. So it means it's going to be this number. It is the median number. So if inside of the array, maybe there are 4 ones, maybe. Yeah, so this is 0, and this is 1, this is 1. So if there are 4 ones, what could be the meeting point? It could be this one or this one. It must be the median number. So in mathematics, the median number is divided by the total number of ones, if it is even or if it is odd. Definitely it is n divided by 2. So the index is going to be starting from 0 to n minus 1. Yeah. So this is going to be the definition for median in mathematics. For 1D array, we think that is okay. We can use the median. But what if it is a 2D array? So currently it is not a 1D array. It is a 2D array. Yeah. So let's just use a 2D array. It's going to be a matrix. So we still have some values, maybe 1, 0, 1, and 0, 1, but we have another 1D array, so it's going to be a 2D array. So here maybe I'm going to use a 0, 0. Yeah, we just maybe use yeah, I'm going to change a little bit. maybe here is 1, and this is a 0, and this is also a 1. So currently we have a 2D array. But if we have a 2D array, how can we calculate the median? Actually, it is similar to 1D array. Yeah, but we just need to check how many ones. So in each row and each column. So this is going to be row 0 and row 1, and this is going to be column 0, 1, 2, 3, and 4. Yeah. So for checking the each of the row, we just need to check how many ones. Yeah. So for 0, there are 3 ones. Yeah. So if there are 3 ones, definitely we want to put the row index. So this is going to be a row index array. So it's going to be 0, row 0, and row 0, and this is the row 1, and this is the row 1. So it means we have 3 zeros and 2 ones. This is for the for the row sum array. Yeah, and similarly we can also prepare the column sum. Yeah, so for the column sum array we just need to put the index inside. So for index 0, we have 1 0. So for 1 we don't have anything, and for 2 we have a 2, another 2, index 2, and what about index 3? We don't have. And for index 4, we have 1 index 4 and another index 4. Yeah, now we are going to check the median, because as the row sum and column sum array is sorted in increasing order. Yeah, so if it is sorted in increasing order, we can check the midpoint. So this is for the row. It means it's going to be row 0. So what is going to be the column? Yeah, because 1, 2, 3. Yeah, let me just think if everything. Yeah, I think I did something wrong. For the column, it is okay for my calculation. Yeah, let me just make it right, because for the rows I did something wrong. Yeah, let me just think about it. I think it is okay. So for the row, yeah, I think it should be okay. Let me go back. Yeah, so for the row 0, we just need to check the index. We have 3 index, so this means we're gonna put 3 zeros here and 2 1 here. So for the row, the midpoint is gonna be the 0. What about the column? So the midpoint is gonna be this number 2. Yeah, so this means for the coordinate 0 and 2 gonna be the meeting point. So it's gonna be this one. Let me just use another color. So this one gonna be the meeting point. And let's just calculate it. So the distance from here, it is 2, and this is also 2. 2 plus 2 plus 1, it is 5, and then we plus this one. 1, 2, 3. So it's gonna be 8. Yeah, so the minimum distance is gonna be 8 for this point. But if you don't believe it, maybe we just use another point, maybe here. Yeah, maybe we're gonna meet here, or maybe we're gonna meet here, maybe this one. Yeah, let's just calculate it. So if this is a 1, so the distance is 1 plus 2, it's gonna be 3. And what about this one? It's gonna plus 3, it is a 6. What about the last one? 7, 8, 9, 10, 11. So if this is the meeting point, so the distance is gonna be 11, as you can see. Definitely we're gonna use this kind of idea to find the midpoint. If we can find the midpoint, definitely we can use a brute force to check the total distance. Yeah, because we've already found the meeting point, we can directly calculate it by using the brute force. Maybe this is the meeting point, and we can use brute force to find the distance, and then we can finally return this kind of distance. Yeah. Now let's just have a global view of the question, why we can solve such kind of a question using by using the median in mathematics. Because normally for a 1D array or 2D array, definitely we have a lot of ones. Currently, we will not consider the zeros because we will ignore that. Maybe we're gonna always use 1. So there are gonna be a lot of ones, and this is just a 2D grid. And inside, maybe, if there are some ones here, and there are some ones here, and there are some ones here. So what could be the median position? So for 1D array, we should know that it should be the median and maybe here. But this is a 2D grid. Maybe the median point is somewhere just in the middle. Yeah, it's just like when you calculate the median position for a triangle. It must be in this position. And similarly for this one, if there are some ones, the median point may be just here. And how can we calculate that? And we can directly, just accumulate the row sum and column sum and find the median position. And definitely the position is going to be here. Yeah. And now let's just implement the method of the median in mathematics. So first of all, we're going to prepare a row and column. I think the coding is going to be much easier, but it's really difficult to think about this kind of a mathematical idea to solve the problem. Yeah. So we're going to prepare a row sum and column sum array. It's going to be 2 empty array. Now we are going to look through the grid. So for R in range, capital R, and for C in range with capital C. So if grid RC, so if this is a grid, so for the row sum, I would to append the R. Similarly, for the column sum, I'm gonna append the C. Yeah. So this is a row sum and column sum array. So after I get this kind of array, let me just print out what it looks like. Maybe we can understand it easier. Let's just print out. Let me just return a random value. Let's just check what is inside of the row sum and what is inside of the column sum. So as you can see, the row sum going to be something 0, 0, 2, because this is a 0, this is a 0, and this is a 2 for the row. And for the column, it's going to be 0, 2, and 4. This is why. And if we can get it, so finally we just need to sort it. Because we need to find the median position. So the row sum, we're gonna sort it, and similarly for the column sum, we also need to sort it. So after sorting, we can easily get the mid position. So the row made and column made. So it's gonna be the row sum. So inside it's gonna be the length of the row sum divided by 2. This is gonna be the median position for the row, and similarly for the column. So it's gonna be the column sum, and the inside it is gonna be length of the column sum, and divided by 2. Now we find the median position for the row and column, and we just need to use a final 2 for loops to get the final result. So for R in range, capital R, and for C in range with C. We're gonna accumulate all the values inside a result. So we need to check if there's a value, because we only consider the value which is 1. We don't need to consider the zeros. Definitely the zeros is not the final answer. So if grid RC, and we just need to accumulate the values according to the Manhattan distance. It's going to be the row made minus R plus the absolute value of column made minus C. And finally, we just need to return the result. So this is going to be the solution for the problem. And now let me just run it to check. As you can see, it works. Now let me submit it. As you can see, it works, and it's pretty fast because the time complexity is mn times log mn. So because here we used a sorting, and inside of the sorting array, the maximum total length could be mn. So this is why it is mn times log mn. So log mn is going to be the final time complexity. Thank you for watching. See you next time.